All right, in lesson 9A and 9B, we're really going to be looking just more at percentages and how to interpret data that's given as percentages. So even though it says it's comparing categorical data, we are going to be comparing categories, and we're going to be comparing them by looking at percentages. It says Grace Healthcare Systems has received a grant to allow participation in the 100,000 Lives campaign. The grant affords the implementation of only one bundle. And one bundle is going to be referred to one set of activities. We'll see what that is in a minute. An implementation team has been chosen to decide which bundle to adopt with the limited grant dollars. The team will use the data to guide their decision. The team is deciding between the ventilator bundle, which helps prevent hospital-acquired infections from ventilator treatment, or the central line bundle, which helps prevent hospital-acquired infections from a central line. I'm sure most of you are familiar with ventilators during this COVID period. Ventilators, of course, were when people who can't breathe any longer are placed on a ventilator. The other treatment that they're talking about is called a central line. A central line is an IV line that goes directly to your heart. Most of the time, you do not have a line that goes directly to your heart. I just want to look at our objective, and our objective is the idea that percentages involve a numerator, which is a comparison value, and a denominator that's a base value. We're always going to be comparing one value to a base. It says Amy and Trevor are on the implementation team and are using the data summarized in the table below to guide their decision. The table excludes patients who received both treatments. So all patients in the table received only one treatment, central line or ventilator, not both. Take a moment to acquaint yourself with the table and then complete the table. So just if we look, we've got a column for central line patients. We have a column for ventilator patients, and then we have a total. And then horizontally, we have a row for those patients that developed hospital-acquired infections, HAI, a row for patients who did not develop an HAI, and then the total. So if we go across, we can see 20 central line patients developed an infection, 22 ventilator patients developed an infection, for a total of 42 infections. We can see the total number of people that received a central line was 82. So if I do 82 minus 20, it looks like 62 people did not get an infection from their central line. Over here we see patients on a ventilator. 22 patients got an infection. There were a total of 118. If I do 118 minus 22, I'm going to get 96. So 22 plus 96, there's my 118 ventilator patients. This total should be the same no matter whether I add this vertically. If I do 42 plus 158, that comes out to be 200. But if I do 82 plus 118, that also is going to equal to 100. So it's kind of a check. The columns all add up to be the total across the bottom. Excuse me. And the rows also add up. So there's our table. And there they've completed it for us. It says, looking at the table, Amy says the hospital should implement the ventilator bundle since more than 50% of the hospital-acquired infections involve patients on a ventilator. Is Amy correct? 50% of the hospital-acquired infections. Well, How many acquire infections? 42 people. She says more than 50% involve patients on a ventilator. This is the ventilator. In this case, our comparison value is the 22, and our base is the 42. You can tell the word base because it'll usually have the of in front of the hospital-acquired infections. That refers to the total number of infections. If I change that to a percent, if I just put 22 divided by 42 in a calculator, you can see that it comes out as a decimal of 0.5238, or if we make that a percent, that's going to be 52.38%. And if we want to, let's round that to the tenths. Let's practice our rounding. That's the tenths place, but since this is more than 5, that's going to be 52.4%. So yes, Amy is correct. When you look at the number of people who got a hospital-acquired infection, there were 42 of them. More than half of them were ventilator patients. It was almost equal, 20 and 22, but more ventilator patients for sure. Trevin disagrees. He says preventing hospital-acquired infections from central line infections is more important because nearly 24% of central line patients develop a hospital-acquired infection, but only 19% of ventilator patients develop a hospital-acquired infection. Is Trevor correct? Well, let's look. 24% of central line patients developed an infection. So in this case, for this first statement, of central line patients is our base. There were 82 of them. How many got an infection? 20. Notice you're always going to be comparing usually either to the total sideways or to the total down below. In this case, we're comparing that 20 out of 82 got a central line infection. I'm going to multiply by 100 to make it a percent. 20 divided by 82 times 100. That's 24.4%. That's actually a little over 24%. And only 19% of ventilators. So now we're going to look at ventilator patients. Again, we're comparing, here we are comparing these two, and here I'm comparing this to this. So if I look at 22 out of 118 times 100%, I'm getting 16.9%. Now let me double check that because I'm getting different numbers than Trevor got. 1/4 of central line, he said nearly 24% of central line patients. Well, 20 out of 82 central line patients is a little over 24%. 22 out of 118 ventilator patients. Oh, I mistyped previously. So yes, that's why I didn't get the right answer. I thought that didn't look right. Let's recheck that. And that will be 18.6. So yes, he's true too. This is about 24%. This is about 19%. So it's true. Percentage-wise, it's more dangerous to get a central line. However, more patients are put on ventilators. So that caused more people to get an infection. If I was trying to make a decision, I would look at which truly reduces the most infections, and I would probably choose to do the ventilator. It's true that mainly because that's going to ultimately reduce the number of patients who get sick. If I can save 22 patients instead of 20 patients, that would be my choice. Even though a central line, when you look just at central line is riskier than a ventilator. But ventilators are more common and therefore are affecting more people. So that would be my choice, which that's what they just said, justify. I would choose, my choice would be the central line. And I really made that choice off the raw data. It helps more people. 22 compared to 20. So I didn't use a percentage to make my decision because I thought ultimately which is going to have a greater effect on the number of lives. Okay, that's just moving into part B. It's more of the same. It says, as you saw in the previous lesson, statements about percentages are often confusing. Recall that HAI stands for hospital-acquired infection and consider the following two quantities. Quantity 1, the percent of ventilator patients who developed a hospital-acquired infection. The percent of ventilator patients who got an infection. So we're only looking at ventilator patients. That was 22 out of 118, which we already said was 18.6%. Quantity 2 is the percent of hospital-acquired infection patients who are ventilator patients. If we look at, remember, percent of, this is our base. There are a total of 42 infections. That's our base. So, how many of those sick people were ventilator patients? 22 out of 42. That's 52.4%. We're looking at different bases. This was strictly looking at the percentage of ventilator patients who got infections, 22 out of 118. The second question looks at the percentage of all infections who happen to be ventilator patients. If we look at all infections, which is 42, 22 of those were ventilator patients. So we have to pay attention to what our base is. Percent of ventilator patients here, percent of hospital-acquired infections here. In both cases, the comparison value was the same, the 22, but the base was different. Is Q1 the same as Q2? No, we've already talked through. How many patients on a ventilator get a hospital-acquired infection? Well, there were 118 on that ventilator, and of those, 22 got an infection. That turned into 18.6%. This compared the patients who got an HAI. How many got an HAI? 42. How many of that 42 were on the ventilator? 52.4%. So it does definitely matter what you're comparing to. Okay, so we want to really emphasize here What are we comparing and what is the base value? This comparison will always be part of this whole, because percents are always comparing part to a whole normally, but the comparison value will be part of this whole value. And then we want to be able to correctly identify the quantities involved in a verbal statement about percentages. And that's the tricky part, reading those words and making sure we understand what they're talking about. Which quantity does the pie chart represent? Quantity 1 or quantity 2? It obviously represents quantity 1. 18.6 is about a fifth of the circle. Okay? 52% would be over half the pie chart. So there were 18.6% that had an infection. That meant the rest did not have the infection. Right? Label the pie chart below to represent the quantity that you did not choose. So this dark half is patients with an infection. And of course, the light gray is the patients without. Both of these were ventilator patients. No, wait a minute. Let me go back. Were they ventilator patients? Yes. Making sure for this story. They were both the dark and light gray were ventilator patients, but they're saying 52.4%, a little over half, had an infection. The light gray is the ones that did not get the infection. The Center for Disease Control and Prevention, the CDC, estimates that 4.5% of hospital admissions in America develop a hospital-acquired infection. Hospitals and health networks daily report that almost 1/3 of these infections derive from the insertion of a central line. Moreover, the goal within the healthcare system is to reduce infections due to central line insertion by 50%. So our first question, approximately how many hospital admissions develop a hospital-acquired infection out of every 1,000 U.S. hospital admissions? Well, they tell us 4.5% of hospital admissions. So if we have 1,000 hospital admissions, we want 4.5% of 1,000. That's 0.045 times 1,000. Or 45 patients. So 45 patients get that hospital-acquired infection. And you can double check that. 45 out of 1,000 is going to be 4.5%. So 4.45 patients out of every 1,000 patients. How many hospital admissions develop a hospital-acquired infection out of every 1 million? Well, that's just 1,000 times bigger, but it's the same 0.045, that's 4.5% times 1 million. So instead of 45, it's going to be 45,000. Again, if you wanted to double check that, you could. 45,000 divided by 1 million. Notice all of that cancels out. That's the same 4.5%. It says approximately how many hospital admissions out of every 1,000 leads to cases of hospital-acquired infection attributed to central line insertions. Well, we may need to go back and read. Let's go back. It says, whoops. It reports almost 1/3 of these infections come from central lines. So we want 1/3. Well, what is 1/3 of 45,000? That's going to be 15,000. So 45,000 out of every million get some type of infection. 1/3 of those infections come from central lines. So 1/3 of that 45,000 is 15,000. So we get 15,000 patients who get an infection due to a central line. Part D, assume the healthcare system meets its goal of reducing hospital-acquired infections due to central line insertions by 50%. Making this assumption, approximately how many hospital admissions out of every 1 million U.S. admissions will lead to cases of HAI attributed to central line? Well, our current was 15,000 out of 1 million. If we want to reduce that by 50%, we need to understand that 50%, you should know this by heart, is just 1/2. You want to cut the infections in half. To cut something in half, you can do it a couple of ways. You can either say, hey, let's just divide 15,000 by 2. That's going to be 7,500. Or you can multiply by 1/2. That's also 7,500. Same thing. Dividing by 2 is the same as multiplying by 1/2. So if we can cut the infections down, there'll only be about 7,500 patients that will get this hospital-acquired infection due to a central line. Suppose a particular hospital with 10,000 annual admissions has a HAI incident rates on par with the CDC estimates. How many annual incidences of central line infections should the hospital not exceed to meet the goal of reducing these infections by 50%? Well, let's just go through the process. We know that 4.5% get some type of hospital-acquired infection. 4.5% of 10,000 patients is 450 patients a year. We know that in the past, 1/3 of that amount are central line infections. So we say 1/3 of 450 is 150 infections in patients, right? That's the number of patients that get central line infections. Okay, we want to cut that by 50%. Cutting that by 50% means cutting it in half. Half of 150 is going to be 75 patients. So they need to cut down the number of patients from 150 to 75. I know that gets confusing. Just go slow and make sure you know what quantity they are comparing, what is my comparison value, and what is my base value.